doing some research and learning about geometry scripts. So I believe I have to add it to the plugins. But I think that this is something that I can use to probably generate the type of procedural structures I'm looking for. Plugins, hello. There it is. Geometry script. Yep. Alright, gotta restart. So I'll be right back. Save all. Now that I'm satisfied with the procedural nebula texture and the particle system, it's time to look at procedurally generating the three-dimensional meshes that I can use to truly make nebulas from scratch. And I got a drink that I'm sipping on too, so. Alright, I'm back. Just installed the geometry script plugin. You can see here the nebula particle system I've been working on. Procedural, there's all kinds of attributes and colors and things you can change here to customize this. All right. So, what is next? So we have a particle system that takes a mesh and generates nebulas along the space of that mesh, along with our volumetric material. So right now I just have canned meshes that I give it. For instance, if I were to go to this guy and I were to change this to the space donut instead of the space fork, then we would have a ring instead of like a forking object. Now we have a ring. So next I need to be able to create a mesh, and it doesn't have to be a complicated one, procedurally at runtime, and then feed it to one of these systems, and that's how I'm going to be able to get a huge amount of variance on this system, at least I hope. So next, so now I have to learn about geometry scripts, and part of that is going to be me watching YouTube videos. And that's just the way it is. Collisions, nanobreaking, geometry scripts. I have one for creating tentacles.
I went over to my family's house for
this
dinner
is moist critical.
Hi, welcome again.
No, this is not. Where's the tentacles? So I like the idea of tentacles or cables or things like that, because here it is. Because that's kind of what I'm looking for, is like kind of snaky patterns, and I can jitter the spawn, so like honestly, like even just a path would be fine. This is cool. All right. Alter my state a little bit. Take a booze drink. And take a hit. I wonder if he's going to see something like this. Like that branching. It would be quite good. I don't think this guy's going to show how to do this. Okay. This guy's not showing how to use it. How do I just want to get started. Dynamic mesh, no. Getting started.
In this video, we are going to look at Unreal Engine 5 geometry scripting plugin and what we can do with. For example,
Here we go.
here we have some nanite meshes. I can show you. And these static meshes are generated inside the Unreal Engine. And I can show you. Here we have a sphere like this. And this is a dynamic mesh that we are going to work on. Inside this, we are generating a sphere mesh. But of course, we can introduce any other existing static mesh as well. So here we have a rubber toy from Houdini. So this is my source mesh and I can apply displacement. Right, then I have something like this. I'm gonna hide this, right? Okay. Now I need to give a little bit more displacement, like 20, and it's kind of visible over here. But this is not a nanite mesh, it's a dynamic mesh.
That's
so now
cool.
I'm gonna transfer this mesh into these nanite meshes. It's quite easy. I have set my target static mesh. You can put any static mesh over here. And then I can hit bake mesh and it will take some time. So this is happening inside the editor. As you can see now we have a nanite mesh over here. I can confirm and show you. Right, this is a set of nanite
This
meshes.
isn't
And the interesting thing is these meshes have
what I'm looking
collisions
for
as well.
exactly.
I can play my game. Right, I can interact with them physically. Right, like this.
Yeah, no shit. You can do that with everything.
And I can show you the collisions by going into play collision. So you can see it's sort of boxes, but
Okay.
I'll show you how to
I'm
customize
slicing.
in the geometry scripting. We are not going to use any child distractions or anything. Here, this is a runtime system. You can change it inside the game as you like. For example, I can change the cutting plane like this. Also, I can rotate this as well. And I can simply play my game and cut it like this.
That's
Also,
cool.
this is not specific to this static mesh.
That's
Of
cool,
course, I
though.
can put any sort of mesh I like. So here we have another fruit like this,
Well, yeah, obviously.
and I can simply cut it like this as well.
Yeah.
So I can change the material,
You'd have to-
inside material, and
yeah,
all the
you could-
customizations that you can do. So the
You
idea
could
is
do
if you
like a
have some
3D
imagination on
texture
what
for
you
the
want to do,
inside of a
then
fruit.
basically you could actually do it inside the engine.
And
So that's
then
the
you
whole
can
loop,
make
and
it so
that's
that no matter what
we
way
are
you
trying
cut
to do
it,
here with
it
this
has like
series.
the right
In this
slice.
video, we are not trying to show you how to do this.
That's
But
fucking
basically, there are
cool.
some
It's
things
like-
you have to learn more about,
Oh, it's a lot.
the-
It's a lot of work for slicing a fruit. But I mean, I guess truly there's entire games made out of just slicing fruit, right? Fruit Ninja.
Running, so you can start working on complex and amazing things. And finally, all these
So if
source
you can
files
cut a
will be
fruit, you can
available
make a
on
game.
Patreon, so you can go to our Patreon page and try to grab these files. And of course, you can contribute us and try to encourage us to create content like this quite often. All right, let's get started. First thing is you need to enable a plugin called Geometry Scripting. Go
Yep.
edit,
I did that.
plugins, and search for geometry. Here we have a plugin called Geometry Script, and simply click this checkbox and enable that. So after that, you have to restart your engine and try to do that. And then let's create a new level, basic level, so we can start from scratch. I'm gonna save this as my tutorial level, right? And then let's create a new folder for tutorial, so I can put all the tutorial stuff inside this directory, right? The first thing is we need to create a actor blueprint class, and here I forgot to mention you need to have a basic understanding of how Unreal Engine works and how the blueprint system works in Unreal Engine. And if you have proper understanding, this video will be really easy to follow. But if you don't have that understanding, it's still possible to follow, but it will be hard because
Yeah.
I'm not going to explain some of the specific things related to Unreal Engine and blueprints.
Yep, that's
Then go to the
okay.
actor search area and try to search for actor called generated. Here we have an actor called generated dynamic mesh actor, and that's the actor we want to use. I'm gonna head select, so we can give it a name, any name we like. I'm gonna set hello geo. I'm gonna double click and open that. And this is where I work with the geometry and trying to create interesting things. Here I have arranged my editor window in quite a different way. Here I have placed my viewport into this area, and I have put my components and blueprint section over here, and that's helpful since we are working with geometry. We need to see something all the time maybe. And first thing, let's create a sphere and try to.
All right, hold up. We're gonna make. I think you did actor, right? Let me double check. Okay. Actor. Prong. Neb mesh. Alright. Now what was he doing? He was in the event graph.
Area, and I have put my components and blueprint section over here, and that's helpful since we are working with geometry. We need to see something all the time maybe. And first thing, let's create a sphere and try to get the basics of this geometry scripting system. I'm gonna go to the event graph, right click, and search for event called on rebuild generated mesh. Right, and this is a
Event on rebuild generated mesh. Event on rebuild. Generated mesh. Excuse me.
let's create a sphere and try to get the basics of this geometry scripting system. I'm gonna go to the event graph, right click, and search for event called on rebuild generated mesh. Right, and this is something similar to the construction script, but this will run in a very specific way that it won't affect the performance of your engine, especially working inside the editor. And always try to use this event. In this case, we have something called target mesh, and this is a dynamic mesh that we can add geometry into this mesh. For example, I can grab this and search for append sphere.
I don't have that. I'm gonna have to find a tutorial. Geometry script tutorial. UE5. Hmm.
Alright, let's see. And that's basically it. I append box. Should I update the mesh somehow? Probably not. Refresh. Accept. Commit. Maybe not. Let's try. Compile is here. So as you can see, simple as that. Simple as
Unrebuild generated
construction
mesh.
script, right?
Why do I not have that?
Unrebuild generated mesh.
Event
By the way, the actual
on.
should have a button to reveal. Or maybe they changed it. Ah, no. So now, if you want to prevent changes, if you want to work on your graph, go. Alright. How to create. By the way, geometry script is. I think it can run in runtime. We'll do some string to verify that. That should be great advantage for procedural content generated in the game itself by players. But the most important thing, the most important use case is to kinda have a construction script but run once, right? Properly cached, even saved on disk. That's also a possibility with geometry script. So the first thing we do, we will disable tick in the tablet. We don't need ticking. And also, what may be interesting to you, we don't use the construction script at all. Instead, we go to functions, click override, and on the bottom we have on.
On rebuild. Why don't I have this? I should have the plugin. Oh, this one.
But the stars themselves, as we had on the reference, and you can see like a CT scan, even software. You have this, and as you can see, if we had more layers than this, we would be very close to an actual 3D preview. Kind of convert like that. Cool. Material function. Some cake designs that we can try back. Learn. Okay. I don't get that. And this, let's say, parallax effect is not consistent with the change in 3D. But oh well, here we are, so I don't know. Anyway, let's take it to here. Because we also have that. Oh yes, and here it is. And I move it upwards. Yay. Okay, cool. So
Then of course the other option, like these don't have to be super dense meshes, so you could just make a bunch and have them like rotated in different ways. to think carefully about how I do this. So one option would be to make like agree to fill in. How do I make? Okay. This is where I don't even really know where to start. How do I just okay? UE5 geometry script tutorial. Intro. I don't want to make stairs. I want to make like a snake. Snake.
Hello everyone. So today I'm going to work on this procedural snake character. So here is the preview. So as you can see, this snake character is implemented procedurally. That means there are no animations, but this tail or the body of the snake is coming, dragging behind the character, regardless of whatever the turns we take in the world. So yeah, so I know this is not a complex or realistic character by any means, but this is just something I wanted to test and see how it turns out. So this is the end result we are going to get today. It's supposed to be a snake recently, and rather than the character works, step and this value, and I make it 1000. We can get the ISM, and first, as we are going to manipulate the locations, I think it would be better to save the location of each port. First index 0, last index instant count. No, not instance count -1, because the indexes is starting from 0. And here again, from the ISA, get instance transform, and with this index I'll use the world space tick. Since this is detached from the parent, I don't think that would make a difference, but anyway, I'll keep the world space. And we need to save this transform into an array. So I'll add a variable instance transforms.
How do I make
It should be the
tree in Blender?
Control R to cut the default cube in half. Scale up the middle and scale down the sides. With those top two faces selected, start control right clicking to extrude up your tree, scaling it.
Hold on. Too fast. No. Alright.
Control R and cut the default cube in.
Edit mode.
In half. Scale up the middle and scale down the sides. With those top two.
Okay. Okay. Good enough.
Two faces selected. Start control right clicking to extrude up your tree. Skip.
Control right click.
Scaling every once in a while. Here we can split our tree, extruding right with one branch and left.
Alright, this is great. Hmm. Alright, this should be fun.
left with the other. If you feel need for some reference, add in an image here, a branch out there, and you got a decent looking tree. Using the images as planes add-on, import the branch texture. Align the origin point up at the start of the branch and add in 4 loop cuts. Cut around that branch now and delete the excess faces. Add some variation to that flat plane. Create a new vertex group for that tree. Select the outer branches and assign. Use weight paint mode for tweaking. New particle system. Choose hair, make that 10. Choose
This
a
guy's
to
insane.
render, choose object. Object is that branch. Select the vertex group we made. Choose rotation and global Z. Randomize to pull those branches down. Some random phase and random scale. And 300 branches. Now with an HDR loaded, choose transparent. For the branch material, add an add shader and a translucent shader connecting it to the bottom. Connect up the color. We have light passing through our tree. Add a bar texture for the tree. Unwrap with U. Smart UV project. Scale and UVs up. And the specular and normal maps. And by golly, we grew a tree.
Very useful. Okay, so now
Control R and cut the default cube in half. Scale up the middle and scale down the sides. With those top 2 faces selected, start control right clicking to extrude up your tree, scaling every once in a while. Here we can split our tree, extruding right with one branch and left with the other.
subdivision surface. Where is it? There.
Branch out here, a branch out there, and you got a decent looking tree. Using the images as planes add-on, import the branch texture. Align the origin point up at the start of the branch and add in 4 loop cuts. Cut around that branch now and delete the excess faces. Add some variation to that flat plane. Create a new vertex group for that tree. Select the outer branches and assign. Use weight paint mode for tweaking. New particle system. Choose hair, make that 10. Choose advanced. Under render, choose object. Object is that branch. Select the vertex group we made. Choose rotation and global Z. Randomize to pull those branches down. Some random phase and random scale. And 300 branches. Now with an HDR loaded, choose transparent. For the branch material, add an add shader and a
Something like this. Alright.
Color, we have light passing through our tree. Add a bar texture for the tree. Unwrap with U. Smart UV project. Scale and UVs up. And the specular and normal maps. And by golly, we grew a tree.
Okay, got that. Be right back. Here's this. Oh, I fucking guess I exported it wrong. File, export, FBX. Wait, hang on, cancel. File, export, FBX. Same thing. Path mode copy. Mesh only. Selected object. Export. Let's try this again. Damn it. Yeah. Do all this stuff. We don't need collision. 5. Import. Alright. Let's see how this this works. Importing. Alright. This we'll do. Save it. See what this looks like now. So I just need to up the material a bit. That's this. How about 0.3 master opacity? How about that? And then it's a larger structure, so we'll give it a little bit more of this. And then next we can grab this. Oh, I lost it. There it is. Flew into a dust cloud. So I just got to figure out how to make these type of objects procedurally. That's interesting. It's a bug. Alright, hold up. Kind of like that. Is this where they cancel out at? Yeah, it must be. Okay. So I know what I need to make, which is like something that looks like this basically. And I need to be able to make this programmatically though, and randomizable. And in different modes. Like some of them should have like a big cloud, some of them shouldn't. If I up this to like 1,000. No, it's like almost too much. 100. 100's not enough. 400. $600. I don't know what's going on with that, but like when I look past a certain angle, am I upside down? No. All right, so That's kind of a cool effect. The low grade one. Completely different. So cool. Excuse me. This is the part that I'm not sure about. I don't know how to do the static mesh shit. I've never done that. So I'm kind of stuck. I'll probably have to have like a brain breakthrough to even get started on it. It is pretty fun just fucking around with the settings on this. We'll find a movie to watch in the meantime. Sorry if I'm not saying anything. I'm just reading shit on the other monitor. UE5 generate static mesh at runtime. Bake the static mesh from geometry scripts. I'm beginning to suspect that the answer is going to be to just generate a bunch of fucking 3D objects. So I had another one that I wanted to try in Blender. Have this now. Make like a Mm. Ooh, the distortion stuff's gonna be good for a star as well. So, idea occurs to me. Noise, one, number two. X coordinate. Plus times Yeah. All right. Still not quite ignition, huh? Needed some bloom, but that means I need to look at this too. No, it's still working with bloom. Okay. Bloom is going to be necessary to make the star look right. Yeah, we can have lots of fun with this. It's the sun. So now what if I Alright, so this is way too bright right now. Obviously. Let's try an order of magnitude less. Hold up. Should be bigger. It's still too bright. Let's bump it down by 1/3. seeing texture coming on that thing. Alright. How about a mere 100? This is something has gone wrong here. This is not updated. Okay, I know what's going on now. Yeah, this made sense here, but this scale needs to be way smaller. We'll try 100. Yeah, and that's still too, but it's getting there. So 10 times smaller than it just was. There we go. And now we can ramp this back up a smidge. And now if I go to this guy, I could go and I could give him some colors more appropriate to the star it's next to. This is too big now. Let's double it. See how that looks. What is this thing? Am I going up or down? Okay, I went up. So that means bigger number equals smaller noise. So well, pretty cool. There we go. That's the effect I was looking for. And now even when we get close, we should still have a pretty good amount of glare out from the rim. I'm dead. So I need to get these concepts all bottled up and organized and such too. Because I've kind of just been working in the root directory, which only works for so long. Alright. Trash can. Put it back. And then space fork. Space. Then we can just take this down to 4,000. No, not you. I want to be able to do one more thing. So, Proc Nebula, right? Has this guy. Right here. Um, can make this like a 0.1. Let's see it. This should be interesting. It'd probably have to be way slower than 0.1, but we'll get the picture pretty quick. Add the ability to have it subtly shift over time. Seems useful. That's fucking cool, dude. Damn. Now what I could do, for instance, is I could shrink this down to like right here. Let's take this and put it at 0. And let's take this and put it at 0. And then use it almost like the sun's corona. And then if we were going to do that, we could also use this, a healthy luminosity boost. Oops. Then go back here. Give it some real luminosity. Turbulence, multi. Goes way up. So here's a way that we can use this basically to enhance a star. Pretty cool. Let's explain about before. And three. I think 3 looks pretty good. Then pretty cool. And then we could oh no, I crashed. Well, that's a pretty good stopping point. Cool stuff. I guess I didn't do any geometry scripts. I looked into it, but maybe I should look some more into those. I got sidetracked using the volumetrics with the star. Oh no. Okay, no, I didn't lose it. I was like, oh shit, did I just lose the whole thing? But I didn't. It's just cool. Well, I think I cracked the code on Nebulas. I was stuck on this for a long, long time, trying to do like various things. It was all about distortion. That's all I needed. Man, you could use this for all kinds of shit. I think you could probably get an explosion out of this. Some fire. Alright, here we are at 0, 0. Let's make a shapes sphere. It gets the sun texture. It gets big. This gets big. Wait. Oh no. There it is. Alright, send you to 0. Make you much bigger. Not that big. Close. A little bit bigger. I really do want the edge geometry to be kind of indiscernible so that it seamlessly blends between the volumetrics and the star. So you need a lot. A huge multiplier on the Fresnel. Well, that looks pretty good. That's cool. Time multi 0.03 star speed 0.03. Let's try it. Oops. Not bad. This. All right. Okay. Pretty good looking star. So how do I make a here? And okay. I just don't know what I'm doing with that yet. Gonna take some more time. Quick star box texture UE5. Quick star. So I'm a little frustrated because I'm supposed to have this event on rebuild generated mesh from this plugin, and I don't.
That. So after that, you have to restart your engine and try to do that. And then let's create a new level, basic level, so we can start from scratch. I'm gonna save this as my tutorial level, right? And then let's create a new folder for tutorial, so I can put all the tutorial stuff inside this directory. Right. The first thing is we need to create a actor blueprint class, and here I forgot to mention you need to have a basic understanding of how Unreal Engine works and how the blueprint system works in Unreal Engine. And if you have proper understanding, this video will be really easy to follow.
Oh,
And
I
if you
bet
don't
I
have that,
made the wrong fucking
understanding,
class.
It's still possible to follow, but it will be hard because I'm not going to explain some of the specific things related to Unreal Engine and blueprints, right? And then from the actor search area and try to search for actor called generated. Here we have an actor called generated.
That's what it is. Can I now delete this? Oh, right. There we go. I was like, I can't do it. There it is. All right, now I'm in business.
I viewport into this area, and I go to the wireframe.
All right, burn one and then follow this tutorial. The stretch. Okay. I got my booze drink here. I need some music too. Or like a movie. So basically, I want to take a mesh and do like some random shit to it and create like a random core pattern that I can then use in the mesh in the nebula generator. And I'm going to use that same nebula texture, but a different instance of it for star corona, because why not? I also can experiment with the types of noise I'm using, which would be interesting. What I actually need to do is make multiple different copies of the nebula and name them after the type of noise it used, if that proves to be a worthwhile thing to do. So like for instance, I could come here, right now it's gradient, and I could change it to computational gradient. Save it. Oh god. I think this defaults to 0, but this is like the how big the chunks are in your random generation. I just have fun playing with these textures, to be honest. This volumetric shit is cool. Alright, let's take a look what that looks like. About the same. About the same. Now, what won't look the same would be like a Voronoi or... See what the fast 3D gradient looks like. I wish this didn't take so long. See what the difference is with simplex. We want to use the cheapest noise that still looks good. Obviously, this is a expensive shader. What changed? I mean, the scale's different. No, I don't think I like that. Yeah. And, so fast gradient 3D texture. Actually, I do want to see Voronoi. Now, this is the last one. After this, probably just going to fast gradient because that looked good and it is apparently cheaper. I thought it would be more expensive. Oh, it's so painfully slow. Oh my god. This is Voronoi. Honestly, Can't tell too much of a difference, so I'm just gonna go back to fast grading because that seemed to be the one with the least computations, and I'm gonna save it. Looks good. All right, good to go. And with that, go into this. Alright. Now, where is my fucking guide?
Mode. So this is my wireframes, and here of course you can put the steps X and Y and Z and try to increase some geometry, but I'm gonna subdivide instead of that. To the target mesh and search for subdivide, and here we have a couple of subdivision options. In this case I need more triangles, not to smooth the mesh, so I'm gonna set this apply triangle loop sub D or uniform or this one. And if you put the Chapman-Clark subdivision, it will try to smooth the mesh, and that's not what we want in this case. So I'm gonna select this one. About subdivision, let try to put out 3 times, right? And it will give me enough geometry that I can work with, I guess so. Then I'm gonna get this target mesh, and I can search for displace. So we have a node called apply displace from texture map. So we are gonna use a texture to displace this mesh. Now I'm gonna promote this texture into a variable. I'm gonna say that displacement texture. I'm gonna hit this.
Could I displace it into other cloud textures and then make clouds from clouds, maybe?
Options and split structuring. And
I heard you like clouds, so I got clouds for your clouds.
So this is the displacement amount. I'm gonna also put that into a variable. So I'm gonna expose that, and I'm gonna rename it as displacement magnitude. If you compare it over here, nothing happens because we don't have any textures. But of course now we go to the editor. I can put some textures and work on this. Now I have already downloaded some Megascan textures and this like pebble texture. So I can try to displace using this texture. And here with the Megascans, now we have pack texture. So this is basically ORTP. So basically the third channel contains a displacement texture. So I'm gonna drag this one and put it to my displacement texture. And I'm gonna set the magnitudes into 10. Right, now it will try to displace like this, and you can see some geometry like this, and it's not it doesn't look nice, and the reason is we are not generating normals. So now let's try to generate some normals. Then I'm gonna grab this and then search for normals, and here we have something called recompute normals. Right, and I'm gonna compile and save it, and now we have something interesting, but still looks weird. And the reason is here our displacement texture in the third channel, but here in this case we are only picking the first channel. So options image channel, so we need to put this to 2, so it will pick the third channel. But now we have something interesting. I can put the material over here. Now yeah, it looks exactly what we need. And of course if you like, you can add more geometry by increasing the subdivisions to 4, and then it will try to give more details. Okay, now let's try to move this mesh into a different place like this. If you see properly, it's really hard to move it here. I'm not sure that you can see on the video. The reason is, so now every time I move this mesh, it will try to run this function. So it's similar to the construction F script, and this is super costly because we're doing subdivisions, and that's why it's kind of slow. But we can easily fix that. So here's how to do that. I'm gonna select everything I wrote over here, right click, and I'm gonna hit collapse to function. And now let's give it a name like apply displacement. And then I'm gonna enable this checkbox called in editor, so I can access this from the editor as well. But if I compile that, but if you search over here, I don't see this button, and the reason is this function has an input. So that's input is the target mesh. If you have an input over here, you cannot call it from the editor. So we're gonna uncheck this wire, and I'm gonna delete this target mesh. Right now we can call it from the editor, but of course we cannot compile. The reason is we need to put some target mesh over here. We can easily get that, and this target mesh is the dynamic mesh of this dynamic mesh component. So we can grab this dynamic mesh component of this actor, and try to get dynamic mesh. So, and that's same as the target mesh that you have earlier, like this. All right, I'm gonna compile and save it. Then it will give me another warning. I can click somewhere here, and the reason is now this rebuild event, and I'm gonna try to call this, but there is no target mesh, so I can click this and simply hide this. But of course I'm not gonna call this right over here. Now I'm gonna call this function in the editor as I need it. Okay, now if I select over here, there's nothing inside my actor, and the reason is we're not generating anything inside this event. But now instead of that, we have a button called apply displacement. I can click this. Now it will create the displacement and our texture. Of course I can play my game and it's still there, but let's try to move it here and there, but now it's gone. So every time I change my position, so basically every time I try to run this event, and it will reset all the geometry, and yeah, and that's why it looks like this. Of course we can change this. Select the actor, the root component over here, and then we have an option called reset on rebuild. Try to uncheck that. Now it won't reset every time you do some changes. It will try to interact with the existing mesh. Okay, that's pretty cool. But now we have a problem. So here in this case we are trying to add a new mesh every time, and that's not nice. Now what I'm trying to do is I'm going to reset this existing mesh. Every time I click this apply displacement, it's pretty easy. I'm going to grab the return value from this dynamic mesh and search for reset, right, and simply connect it like this. And now we are ready to go. I can compile, save. I can apply displacement once. Now I can move it anywhere I go, and it's quite fast, and yeah, this is exactly what we need. I can play. Yep, everything looks normal. Now we have a mesh, but we don't have any collisions. Now let's try to generate some collisions into this mesh so we can interact with that. So it's quite easy. If you go to this function at the end, simply grab this target mesh after the recompute normals and search for collisions. Here we have a function called set dynamic mesh collision from mesh, but it's quite mouthful. But anyway, you can click that and you can grab this node like this. It's not complete. So basically we are trying to set a collision mesh based on this our target mesh into this component. Okay, so I'm going to grab this component because the collisions are exist inside this component, not inside the mesh, because this collision is also another mesh, so it needs to stay in a place like this. Okay, I'm going to connect this mesh component, dynamic mesh component. Save. All right, everything looks good. And here we have something called options. I'm gonna split that. So now we have some of the options. So here the important option is the method, how we actually create these collisions. By default it will choose the mean volume shapes. It's a good default value. And there's another one called convex hulls, and that's also important in certain areas. So there are some other algorithms you can go through and experiment. In this case I'm gonna compile this, save, and I can play my game. But you can see we don't have any collisions, and the reason is now we need to click this apply displacement once, because everything happens only if you click this button, and that's how we configure it. But now we have collisions. Alright, now we have some collisions, but we have no idea how it looks like, and here's how to do that. Go to your select mode and go to the modeling tab, scroll to the bottom and select the PL inspect this button. And before we do that, try to select your dynamic mesh and then select this PL inspect or P inspect, I guess. Yeah, I can see my collisions. It's it's not a sphere, it's like a volume, I guess. So you can see like this. So like a primitive. It's not a typical mesh, but it's like a volume that you can see. Right? Quite interesting. But let's say we need to change the algorithm. Here's how to do that. And here let's select another algorithm. I'm going to select convex hulls. And I'm gonna compile and save it. But in order to see this, I need to complete this and select this again and apply displacement. Now we have the actual collisions, and then I can hit P inspect, and now we can see something, but not something represent my object. And the reason is here we are limiting the convex hull target face count into 25. In this case 25 is not enough to make a collision for this one. But of course we can increase this number, let's say 100, compile, save, and then again I need to run apply displacement, complete this, and then select again. Alright, now we have something
Okay.
something representing this sphere that we have. I can play my game, right? Like this. Of course, if you like, you can enable the simulations, and inside this component we have option called simulations, like simulate physics. Compile, save, and now you can interact with this sphere like this. Yeah, that's also possible, just like any static mesh actor. Up until now, we have created the source mesh inside the our actor, but usually we don't always work with a sphere. We need to use a custom geometry that we created maybe in another software, for example Houdini, Maya, and so on, or maybe Blender. So here's how to use that. And go to your blueprint, right? And this is the place that we create our source mesh. So I'm gonna select this. I'm gonna right click, and I'm gonna
Pen
collapse into a
sphere.
function right now, and let's give it a name like get source mesh. And I can go inside, and right now this function looks like it doesn't do anything, but right now we're going to use a static mesh as well. If there's a static mesh, we're gonna use that as a source mesh. If not, we're gonna use the sphere. Right, here's the idea. So let's create a variable, and I'm gonna leave it as a source static mesh, and I'm gonna select the type as static mesh, and then I'm gonna click this icon, and now it's visible on the editor. Okay, cool. Now I'm gonna grab this into my scene and get this one, and I'm gonna right click on select convert to validated get. So it's a very interesting function, comes with Unreal Engine 5. So it's a built-in if function. So if valid, you can do something. If not, you can do something. Now I'm gonna connect my execution flow over here. If this is valid, and yeah, let's use this mesh. If not, and this is the fallback, right? And then if it's valid, I'm gonna grab this and search for copy from, yeah, we have a function called copy mesh from static mesh, right? And this is the static mesh, and this is our dynamic mesh. So basically we are asking to copy our static mesh into this dynamic mesh. And with success, usually it is success always, and if not, you can simply show a message, but in this case I'm gonna simply connect this, and this is our updated dynamic mesh, right? And then so nothing happens if you click the apply displacement, because now we're using the fallback. But now let's try to use a static mesh that we already have. I have a static mesh over here. I created this rubber toy. I'm gonna, from Houdini, I'm gonna drag that into source mesh. I'm gonna hit apply displacement. Then it will take a time because it will try to generate too many geometry. I think the reason is, yeah, you can see it's a huge amount of geometry. We don't need that because we're trying to subdivide is quite high. So I can go to my apply displacement function, and I think here subdivision is, let's stick with two levels of subdivisions, because otherwise it will be quite costly, because this original mesh has some geometry in this. Right, now I can select this again, apply displacement. Now if I go to wireframe mode, yeah, it's quite workable. Now let's try to increase the magnitude of this one. Let's put it like 30. All right. So now we have the rock toy. Okay, we can we can name it like this. All right, now this is a mesh, so it's a dynamic mesh. It is not a nanite enable. I can, yeah, you can't see anything. It's just a mesh, dynamic mesh. Now let's convert this into a nanite mesh, and there are a couple of ways to do that. You can select this mesh, go to your modeling tools, and search for transform, and here we have something called convert, and you can select the new access location into current folder, and I can hit convert and accept. Yeah, then it will create a mesh like this, right? And yeah, this looks pretty nice. So that's the way we are trying to do it using this tool set, but of course we can try to do it by ourselves using the blueprints, and let's try to do that as well. I'm going to delete this mesh. Alright, now I'm going to go to my blueprint, and let's create a new function called bake mesh. I'm going to compile and save it, and I'm going to grab my dynamic mesh. You can get the component and search for get dynamic mesh, connect the execution pin, and get this and search for static mesh. And here we have a function called copy to static mesh, so I can move this into a static mesh, right, like this. In this case, we have to provide a static mesh. I'm gonna grab this and search for promote to variable. So I'm gonna rename this as target static mesh, and I'm gonna show that into the editor as well. Compile and save it. Now I'm gonna set this into my default sphere because it's easy to work with, and set the displacement to 10. Now I need to create an empty static mesh so I can work with this one. There is no way I can create an empty static mesh, but I can try to create some base static mesh from the model tools box, current folder, and put it somewhere on the screen and copy it. Alright, I'm gonna go out from these molding tools, and then I can double click on this actor or the static mesh, and here I can enable the nanite support, and as well as I'm gonna search for simple, and I'm gonna change the collision type. By default it's as a complex collisions are simple. I'm not going to explain right now, but this is not gonna work if you're trying to simulate this actor, simulate this static mesh. So in this case, I'm going to select this into the project default or the simple and complex, or simple and complex. Then I can save this. Right now everything looks good. Right, and then I'm going to use this as my target mesh over here in my dynamic mesh. So I'm going to put it like this so I can differentiate both meshes. Here I'm going to set the target mesh as right here. And I cannot see the bake mesh. The reason is I haven't exposed it yet. Now I'm going to see my bake mesh function. Here we have an option called cooling editor. I'm going to select that, compile, save this. Now we have this function. I can click that. Right now you can see it will simply bake the static mesh into here. And now I can basically assign any material I like. Okay, now I'm going to go to the layer collision mode. Right now I cannot see any collision on this because we don't have any collisions, so that's why it looks empty. Now let's try to add some collisions. You can grab this dynamic mesh and search for collisions, and here we have something called set static mesh collision. So earlier we select the set dynamic mesh collision, but now here we have a static mesh. I'm going to select this, and with success. I previously have this, and then I can connect this target static mesh over here. Alright, and now again, just like earlier, we have some options. You can select the algorithm you like. In this case I'll go with the default one. Right now I can hit the bake mesh function again, then I can show the player collisions. Alright, now we have the collisions, as you can see over here. Alright, very cool. So now all I have to do is I can select this, and you can search for simulate, and this is a static mesh actor. I can hit the simulate physics, and I can play with this mesh, and it's a nanite mesh. I go to the nanite visualizations. It's a nanite mesh. Alright, this is the end of the geometry scripting getting started tutorial. I hope you have a good understanding of how to use the geometry script, and I hope this is a foundation for very interesting things that we try to do in the next couple of weeks. Also, I need to give a proper thank to the co-developer of this project, I guess, Ryan Schmidt, and he's quite genius in the mesh modeling area, and he's really helpful on
Input as construction script, right? On rebuild generated mesh. By the way,
just like randomly sized cubes spun around in different directions and spaced out. Could probably do it. The internal polygons are actually fine for the particle effects because that just means it'll generate some on the inside, which is good actually. I think we're getting close. closer to being able to do something. I'm starting to understand.
The actor itself should have a button to reveal. Or maybe they changed it. Ah, no. So now, if you want to prevent changes, if you want to work on your graph, go to frozen and click that. Click that, and then restore. You know, when you want to update this again. If you have some heavy operations, enable reviewed progress. So you see a dialog, but for now it's not needed. Okay. So back to our graph. Here we append the box without the material. Now everything's good, but I don't want the box, so let me delete that for now. And in construction script, in viewport, I'm gonna add my own spline. For now, it will be a hard-coded spline, just for that.
Hole up. Viewport. I want this over here. Alright. Delete this. Okay, I have a spline. Actually gonna move monitors on this tutorial now that I'm working with it.
Just spline. Here it is. And let me just add some
How are you
points.
doing that?
Dragging with Alt.
Dragging with Alt.
Hold Alt and just drag the basic, use case of Unreal splines. Hey, move! Come on. Come on. Okay. And Alt again. And again. Okay. It's a spline. Some simple spline like this. Okay. Let's save it. I don't like this tangent. Maybe now it's better. Maybe it is. Okay. Compile, save. Here it is. Our basic hardcoded spline. So now, back to the event graph. We get our my spline here. And let's convert it to something that geometry script can understand. So let's start by geometry script.
Alright, gotta go back.
or maybe 30.
Hi, welcome again into a variable dynamic mesh component. So we can grab this dynamic mesh component of this actor and try to get it, get dynamic mesh able to follow not to not, and this is the fallback, right? And then if valid, give it as a right now, and it's a custom geometry that we created maybe in another software, for example Houdini, Maya, and so on, or maybe Blender. So here's how to use that, and select get source mesh, and I can go inside, and right now this function looks like it doesn't do anything, but right now we're going to use a static mesh as well. If there's a static mesh, we're gonna use that as a source mesh. If not, we're gonna use a sphere. All right, here's the idea. So let's create a variable, and I'm gonna give it as a source static mesh, and I'm gonna select the type as static mesh, and then I'm gonna click this icon, and now it's visible on the editor. Okay, cool. Now I'm gonna grab this into my scene and get this one, and I'm gonna right click on select convert to validated get. So it's a very interesting function. Type as static convert to validated get. So it's a very interesting function, comes with Unreal Engine 5. So it's a built-in if function. So if valid, you can do something. If not, you can do something. Now I'm going to connect my execution flow over here. If this is valid, and yeah, let's use this mesh. If not, and this is the fallback, right? And then if valid, I'm going to grab this and search for copy from, yeah, we have a function called copy mesh from static mesh, right? And this is the static mesh, and this is our dynamic mesh. So basically we are asking to copy our static mesh into this dynamic mesh. And with success, usually it is success always, and if not, you can simply show a message, but in this case I'm gonna simply connect this, and this is our updated dynamic mesh, right? And then so nothing happens if you click the apply displacement, because now we're using the fallback. But now let's try to use a static mesh that we already have. I have a static mesh over here. I created this rubber toy. I'm gonna, from Houdini, I'm gonna drag that into source mesh. I'm gonna hit apply displacement. Then it will take a time because it will try to generate too many geometry. I think the reason is, yeah, you can see it's a huge amount of geometry. We don't need that because we're trying to subdivide is quite high. So I can go to my apply displacement function, and I think here subdivision is, let's stick with two levels of subdivisions, because otherwise it would be quite costly, because this original mesh has some geometry in this. Right, now I can select this again, apply displacement. If I go to wireframe mode, yeah, it's quite workable. Now let's try to increase the magnitude of this one. Let's put it like 30. All right. So now we have the rock toy. Okay, you can we can name it like this. All right, now this is a mesh, so it's a dynamic mesh. It is not a nanite enable. I can, yeah, you can't see anything. It's just a mesh, dynamic mesh. Now let's convert this into a nanite mesh, and there are a couple of ways to do that. You can select this mesh.
What up?
Yeah, what up, dude?
What are you doing?
And
On a coding bender.
Transform, and here we have something called convert, and you can select the new access location into current folder, and I can hit convert and accept. Yeah,
Do
then
some
you can
stone.
create a mesh like this,
Cool.
right? And yeah, it looks pretty nice. So that's the way we are trying to do it using this tool set. But of course, we can try to do it by ourselves using the blueprints.
What?
Let's try to do that as
So
well.
that shit was
Using
pipe
this
loud.
mesh. All right, now I'm going to go to my blueprint, and let's create a new function called big mesh. I'm gonna come over
Okay,
here.
so I'm like, I
Scroll to the
have
bottom.
2 out of 3 steps done to be able to make like procedural, good-looking nebulas, like not hand tuned, but like with a random number generator, and just have it spit out different ones. And the last thing I gotta do is I gotta figure out how to make it so the way the particle system works is it generates the particles with the jitter around another mesh. So you like feed it a mesh, and whatever shape you give it, it will generate a nebula in that shape. But all my meshes are like manually generated right now, which is not what I want. I need like a function that will generate me a 3D object in like random different shapes. And so that's what I'm trying to figure out now. Because once I have that, I can like automate the whole process. I also found that I can use it for like the corona on a star, and it looks good. So I'm looking into this geometry scripting, which is what I need to be able to do the thing that I'm trying to do, I think.
Okay. So at least you have like, a starting point.
Yeah. It looks like I can like generate geometry. Like I could generate spheres or cubes or meshes and such in this. And if I can do that, then I can have to figure out how to basically make a convincing organic looking structure with it, like randomly. And that's, I'm not sure how to do that yet. So I could loop here. And just append a bunch of differently sized spheres. I really don't know what I'm doing with this thing.
Times 3? Oh shit.
Save, compile. It builds. So look like in the viewport. Okay. I can at least, this is cool. I can at least use it in the viewport. It shows the sphere that it's generating, so that's good, at least.
That's kind of cool.
So now if I do this and I copy
Like
the...
in real time, like you can make adjustments and it shows
Yeah,
you what it
here,
does.
check my stream, you'll see it.
Let me augment some shit really quick. I'm doing some D3 here.
All good.
Changed my mind about the Hearthstone.
Make transform, make relative transform. No.
Oh,
Wait.
goddamn.
Make transform. So if I do like a 10,
Make all 46 of these.
oh no, never mind. It's because of this, actually.
Make all 15 of those. I'm not gonna fucking have enough. Are you for realsies?
As to static mesh. Static mesh. So here it is. All right, recompile, viewport. No, it's not doing anything yet. Geometry script. What does this do? It probably needs maybe it needs a null transform. No. center.
Oh, I found goblin packs.
Two. 20. None of this is doing anything. 100. 10. Alright, I think I just have to continue watching this video tutorial. Loot body. Oh shit. Razor transforms. This guy's using a spline for this. I guess this, I'm just gonna follow this because I like it's gonna. Alright. Delete this. Components. Add a spline. What's a spline mesh? I wanna see it. That's not what I want. Spline. Okay, viewport. No. Alright. Now let's see what he was doing with the spine, because he was splitting, he had some cool shit. Okay, so he made a spline, I made a spline, sample spline and transforms. So there's a node here, sample spline. What is this? 4 months. It should be the same. delete this. If it's not valid is what I'm looking at here. So this comes down into a for loop. And that loop body will do this. And come on, don't crash on me. Don't crash on me.
Oh, you try to do too much shit.
It crashes
Yeah, I like it pretty
occasionally. Yeah, it does.
The fuck you, silly man, you not do that.
Oh no. That's a hard crash.
Seems like I do not support what you're doing. Or not the game, the
Engine. Yeah.
rendering engine.